Hello and welcome to the video tutorial for the Maya plugin called DCC Translation, where we get a very complex Maya scene. We create our own scene graph based on Maya's DAG hierarchy. We export that into an OpenUSD file, which then later can be imported into Unreal Engine 5. The main problem that we're trying to solve is that modern VFX and game pipelines depend on transferring large amounts of scene data between different applications, which often leads to inconsistent assets, failed imports, and time-consuming manual fixes. We had a great discussion with a DNEG VFX specialist, and he highlighted the growing industry need for reliable validation and translation tools to improve communication and compatibility across production pipelines. My name is Felipe Hidalgo. Let's get into it. First, we're going to talk a little bit about the pipeline architecture. It all starts with the Maya scene extraction, where we're going to have, as I said before, a very complex Maya scene based on the DAG hierarchy, where we're going to extract things like transforms, geometry, and metadata. This plugin creates its own scene graph for DCC abstraction as a layer. We're going to have our own nodes, attribute mapping, and an independent data model. Then comes the validation layer. For this validation, we're going to have our own YAML rule profiles, where we can configure our own rules, enable, disable them, set the severity, and these are extremely customizable. Then comes the USD translation layer, where based on our scene graph and YAML profile rules, we create our own USD stage file. Based on the hierarchy, again, it's going to have transforms, metadata, material assignment, and others. This file is going to be exported into the location you want. After that comes the publishing system, where it's going to consist on a translation login where we basically send our data into our database. For the database, we have a backend registry, and this consists that we have more than one database set up for the project or the plugin. And based on the one that it's available, Mongo being the default one, we can always track all the exports of the scenes that we want. We're gonna control asset records, versioning, metadata storage, and audit trail. And the last part of the architecture is the Unreal Engine import. Now that we have our own USD file based on the scene graph that we created, we can open Unreal Engine and import the file as we need in order to get all the assets in a matter of seconds. In terms of questions and guidance about how to run this plugin effectively, please refer to the user guide inside of the GitHub Repository, where we have a specific table of contents and talked about the requirements needed for this plugin to run as intended, all the system dependencies that we need before running the plugin, the Maya 25 setup, where we will need to install a couple of dependencies directly into the mayapy location. For Unreal Engine 5, we would need to enable the USD plugins. We would need to develop an environment setup, create a .env file with a couple of environment variables, and others. Please consult this file. For the installation process and to run this plugin correctly, the first thing that we would need is a very complex Maya scene, as shown here. That's the kitchen set provided by Prixar. The first thing that we would need to do is to drag and drop our file into the Maya scene. This file can be found in the root directory in our GitHub repository. We have our custom login, and what we do is we install our mod file into our Maya path. Then we create our own shelf called DCC Translation and our own button with the label Export USD to Unreal. Once we click on the button, the UI will show up. This UI was created with PySite 6, and what this does is we read all the YAML profile rules that we have in our project, and then we list them on the left side here. Once we click on them, we can see all the different validation that we have and all the different things that we can change. For example, we can have text fields, we can have checkboxes, we can have drop downs, we can have lists where we can add or remove new items. And as you can see, everything is logged. And for example, if we come and we disable this check for duplicate names, we can also save the profile. We can also reset the profile to go back to our default settings. So if we go back, it's enabled. And we can also validate the scene. If we click on validate the scene, for example, This will run the validation, and as you can see, there are multiple errors. For example, the non-frozen transform detected, and also duplicate code names. What we can do is we can update this check for duplicates, we can disable that, we can also disable the require frozen transforms. As we can see, the title is dirty, so once we do some changes, we save the profile, that will be removed. And if we validate again, everything will run effectively and the publish USD button will be activated. Now that the publish USD button is activated, what we can do is we can click on it, we can check and open the folder that we want, and then we can just go ahead and save our new file, and we're going to name it new scene.usda. Something important to mention is that we're validating the extension of the files. Only USD files are accepted. So this means extension USD, USDA, and USDP. Once we save the file, it's going to start the publish portion of the plugin. And as you can see, everything was completed as a success. We used the backend Mongo, and here is the location of our USD file. The next step based on the pipeline architecture would be to import our USD file into Unreal Engine. So first, go into the window section, and since we enabled the USD plugins, open up the stage editor. Click on File and open the file that you desire to import. This is the file that we just created called new scene. We select it and we open it. Once we open the USD, Unreal Engine will import it. And as you can see in the back, we have the kitchen set. Some things we need to consider. Maya sets the up axis to Y, but Unreal Engine sets the up axis to Z. This USD exported for the plugin already corrects that. So everything is set up as default. For example, here you can see that the up axis will be Y. Now that we verified that, we can go ahead and click on Actions, Import. Select the folder or directory where we want all our assets to live in and click OK. This is an important section, and as you can see on the left side are all the USD options or all the type of forms and meshes that we created based on the Maya scene. An important aspect is that we need to disable the use prim kinds for collapsing. By doing this, we're going to have our own individual assets within the kitchen set. If we enable this or set to true, the kitchen set will be one asset instead of multiple. So disable this and import. Now that everything is imported, we can close the stage editor. As you can see, a new folder was created called new scene, static meshes, and in here we can see all our individual meshes. Let's get closer to our kitchen. And if we take a look, everything is exactly the same as the Pixar implementation. We can get an individual asset, for example, as the chair, and we can move it as we need. So this proves that the Maya scene was exported successfully based on the DAG hierarchy. We created our own scene graph. We validated the YAML files based on the UI validator. We exported the USD file, and we imported it into Unreal Engine, successfully getting all the Maya assets into Unreal Engine. Something that would have taken at least 30 minutes, we can do it in a matter of 10 seconds. Another aspect about the project that we're going to showcase is the CLI or command line interface. For the CLI, the first thing that we need to do is we need to sync the project with the UV Python virtual environment. Once we have that, we can call the CLI as UV run, and it's called DCC Translate. If we add the help tag, we would get all the different arguments that are valid, for example, publish, validate, and inspect, with their respective descriptions. If we would go one by one, starting by validate, and adding the help tag, we can also see the options or the different flags that we can set. The second one will be publish, and the third one will be inspect. The first command that we're going to see is going to be validate. For validate, we need the flag DCC and the flag target. For DCC right now we're using a mocked implementation or a mocked Maya scene. We can change this mock value for Maya but we will need the Maya API to be running. So we can run this CLI command within Maya and it'll work. For now, we're gonna stay mock. And for target, we're gonna set on real to validate all the YAML configuration that we would have. If we run the command, the validation will be completed and the scene would pass accordingly. The next command that we're gonna see is publish. Publish is basically the command to export the Maya scene into a USD file. Again, we're gonna use DCC as mock, the target on real, the backend, as we saw before, it's a backend registry, so we can set 2 of them. Mongo is gonna be the default one. For now, we're gonna use SQLite, and the out flag would be the path or the file name for the USD. If we run the command, we can see that the file was created and the registry as well within the SQLite database. We can run the same command again, just changing the backend. We can use Mongo instead, and we will get all the different registries that we have inside the database. The third command that we're going to talk about is going to be inspect, and for inspect, the only flag that we will need is the backend flag. We can set Mongo or SQLite. As you can see, we get the same value as before, and we can also call Mongo. The last part that we want to showcase is the testing, or the unit testing with PyTest. For this section, we implemented a library called Nox. What Nox allows to do is to run different testing using various Python versions. For example, we can run our own UV Python for the local testing, and we can run Maya's mayapy Python for Maya standalone testing. In order to run it, just write the command UV run Nox, set the flag as S, and we can set one flag as local. So now we're gonna run all the local tests. We can also, instead of local, run Maya. We will run only the Maya standalone tests, but we can also run the command all that will combine both. This was a great implementation and helped us test everything within one run. So that was it in terms of the Maya plugin. This tool helped automate processes that took around 30 minutes into a couple of seconds, and also it creates a lot of traceability with all the tracking within the backend. Thank you for watching.